magnetism. The first rule, that is, you know that Ampere swimming law means that the deflection of the directions of the deflection of magnetic needle, and that is due to the electric current, and that can be found by applying Ampere swimming rule. And this Ampere swimming rule is like that, you imagine a man who swims along the conductor in the directions of current facing the needle such that the current enter his feet, then knot of the needle that will deflect towards his left hand. That means knot of the needle that will deflect towards his left hand. So that is, this is the corresponding directions of the current, and say a man is swimming like that, and the thing is that this left hand, that means this man who swims along the conductor in the directions of the current that is facing the needle, the current enters his feet, then the knot of the needle will deflect towards his left hand. That means knot of the needle that is deflects towards his left hand, and from that we will generate the concept that is called magnetic field. And in magnetic field, that means the space or region around the current carrying conductor within which its influence can be felt by the magnetic needle, that is called magnetic field. And you know that strength of the magnetic field, or you can magnetic flux density, or magnetic inductions, or magnetic vector, that is denoted by B. Generally it is denoted by B, and you know that the SI unit of B is Tesla, and CGS unit, if you consider CGS unit, that is nothing but Gauss, and there is a relation, that means 1 Gauss is equals to 10 to the power minus 4 Tesla. That is the basic thing. And the thing is the notational use, that means by using this notation, that means that is a conventional sign for magnetic field, that is coming out of the plane and normal to it, that is coming out of the plane and normal to it, that is denoted by dot. Or you can say that is a similar, in other words you can say that magnetic field that is perpendicular to the plane, in upward direction, and on the other hand there is another notations that is like that, that means magnetic field to the plane in the downward directions, that is nothing but that magnetic field to the plane in the downward direction, directions. So that is the similar representations. And now the thing is that what should be the nature of the magnetic field? What is the nature of magnetic field? And that can be easily you can see it by an experiment. That means if a current carrying straight wire that is passing through a cardboard, that means if we consider this is the corresponding cardboard, and you can say a current carrying conductor, that means current will be flowing through this, and that iron fillings are arranged like that. Iron fillings are put on this cardboard, and now there is no current, and when you are when you are passing a current through this wire, what will happen? You will see that they will make, these iron fillings will make the concentric circle like that, will make a concentric circles like that. So iron filling that will arrange themselves in concentric circles around the wire, and circles formed by the iron fillings are very close to one another near the current carrying conductor, but these circles spread out away from the conductor, and from that we will find, that means a magnetic field around a current carrying straight conductor that consists of a concentric circles of magnetic field lines that lying in a plane which are at right angles to the current carrying conductor. And you can say from that we can find the directions of the magnetic field at any point, that is along the tangent to the magnetic field, and that can be denoted by, that means their current will be flowing through that. Now we are concentrating how we will get the magnetic field, how we will get the magnet, because this is a concentric circle. If you take like that, then you will find the magnetic field will be acting tangentially, and that can be denoted by another rule, that is right-handed screw rule, right-handed screw rule, or Maxwell, that is also known as cork screw rule. That is another rule, that is also the same rule, and where it says that if the forward motion of an imaginary right-handed screw, that means if we take as a screw, uh, and when we are just, this is the forward motion of an imaginary right-handed screw, is the directions of the current, that means screw are moving in the directions of the current through a linear conductor, then the directions of rotations, that means we are rotating the screw in that particular directions, we are rotating the screw, and the screw is moving in the forward directions, and in the forward directions, if it is the directions of current, then the direction of rotation of the screw, that will gives the directions of magnetic field, that means that will give the magnetic field line. Or you can say that that's the same thing, that means the directions of current and the directions of magnetic field, that same thing can be described by another rule, that is called right hand thumb rule, that is also right hand thumb rule. And right hand thumb rule is same thing, that means that if we take as a hand, and these are the like that, and this is the thumb. So if you say that this is thumb will give the directions of current, then the other fingers, that means if a current carrying current is imagined to be held in the right hand, such that the thumb that will point in the directions of current, then the tips of the curled finger, that means if we say these are the other fingers, then the tips of the called fingers encircling the conductor, that will give the directions of the magnetic field line, that means that will give you the magnetic field lines. So that is the same thing, whether you are using right handed screw rule or you can use right hand thumb rule, that both are giving you the same thing. So in that particular case, then we introduce another thing, that is called that Lorentz force, that. And in case of Lorentz force, that means when a charged particle that having a charge q, that moves in a region where both electric and the magnetic field exist, it experiences a net force, that is Lorentz force. And that Lorentz force can be nothing but, you can write the electric force plus the magnetic force, and we already know that the electric force is nothing but charge multiplied by the electric field, that we already know. And magnetic force is nothing but q, and this is v cross b. V is the velocity and b is the magnitude. That means the directions, that means if this will give the directions of v and this is b, and it will make an angle theta, then of course the force will give you that particular direction, that is perpendicular to the plane containing v and b. So that the Lorentz force, you can be written like that, QE plus Q v cross b, and from that if you take q as a common, then it is nothing but E plus v cross b. This is nothing but the Lorentz force. And of course, when the charges when the charge moves parallel or anti-parallel to the directions of the magnetic field, if we consider case 1, that means when charge that moves either parallel or anti-parallel to the direction of the magnetic field, to the direction of the magnetic field, then what we know, that the value of theta is equals to 0, or theta is equals to either 180 degree if it is anti-parallel, And if we put the value in the magnetic field, we have to find the magnetic field, that means Fm, that is nothing but QVB sine theta. And when the sign is 0 or sign is 180, that that is equals to 0. That means no force is experienced by a charged particle when it is moving parallel or anti-parallel to the directions of magnetic field. And of course, when the charge moves at right angle to each other, that means if we consider case 2, that means when charge that that moves right angles perpendicular to the magnetic field, that means V and V are perpendicular magnetic field, then that the value of theta is equals to 90 degree, and this is nothing but UVB, and this is charge is the maximum, you can say that is the maximum force. And when the charged particle is at rest, that means V is equals to 0, and then there is no magnetic force that is experienced by it. So in your board exam, it may come that they will ask you that particular derivations, that means magnetic force on a current carrying conductor that placed in uniform magnetic field. That means the thing is that uh, the result that if we deduce, that means the magnetic force can be written in another format. This is BIL, that means B is the magnetic field, I is the current, and L is the length of the conductor. If you know that, you can solve the problem. That means either you can Q equals to VV, but in boards you have to prove it. That means in boards you have to prove it that from this QVB you have to deduce that particular thing, that is nothing but the magnetic force on a current carrying conductor placed in a uniform magnetic field. And for that we are considering that a current carrying conductor that contains large number of free electrons, and we know that the free electrons are moving within the conductor with a velocity v, that is a drift velocity, and that is in a directions opposite to the the directions of conventional current, because electrons directions and the current directions are opposite to each other. So we know that electrons that is moving in a uniform magnetic field that experience a deflecting force. So what I am talking about, that we are considering, say this is the corresponding conductor, and the thing is that if this is a conductor, we know that the total length of the conductor is L. So we are considering a small portions of it, that is nothing but dl, and that if this is dl, we are taking it, and along the, it should be better if we write along the axis, whatever be the thing, and the force is acting like that. This is the magnetic force, and that is the magnetic field. Now the thing is that we are considering, let this n is nothing but number of free electrons, per unit volume of the conductor, per unit volume of the conductor. And say A is taken as area of cross section, cross section of the conductor, conductor, that is. So what do you know that if we want to consider the magnetic force, that is magnetic force that is acting on an electron, that means only one electron, acting on only one electron, and if we consider this Fm, that is nothing but electron charge V cross B, because we know magnetic force is nothing but Q V cross B, that is the corresponding magnetic force, and that is the magnetic force that is acting on an electron. And of course we know, so if we consider a small element of length dl, that's why we are considering a small element of length dl of the conductor. So the number of electrons in the small element, that is that n multiplied by the volume of the element, and volume means the area multiplied by the length. So what I am talking about now, we consider, because in boards you have to write like that, that means we consider a small element, we consider a small element of length, that is dl of the given conductor, dl of the given conductor, and you know that the number of electrons in the small element, number of electrons in the small elements, small element, that is nothing but n multiplied by the volume of the element, volume of the element, and volume of the element is nothing but cross sectional area multiplied by the distance, we know that is the volume. So that is nothing but the number of electrons in the small element. So now if we consider the magnetic force that is experienced by the element of the conductor, element of the conductor, if we say about that, then what we will get, that is small elemental, that is df, and that is nadl, that is the number of free electrons per unit volume, and adl is the volume, and for each electron we know we find the force is fm, and that is e into v cross b. So what we can write like that, nadl, and it is nothing but minus e, that is v cross b, and that is nothing but naedl, and that is nothing but v cross b. And of course what we know, the drift velocity, this is nothing but the drift velocity, and this is that the, if we differentiate the displacement with respect to time, then we will get the velocity, and that is a negative sign, because that the dl is in the opposite directions of b, because we know the electrons is moving in that direction and the current in opposite directions. And so what we can say, that dl is in a direction that is opposite to v. So what we can say, that that is velocity v. So the thing is that we can place it, and of course what we can say, n is the number of electrons per unit volume, and each electron has charge E, and that is nothing but the total charge in the conductor. You can say that dq is the charge on the small element, n is the number of electrons, this is the per unit volume, and each electron has charge E. So that is the total charge on the small element. You can say dq is the charge on the small element. So what you can say, so we can put here, that means this is df, you can write like that, nadle, that can be written as dq, and in place of v we can write dl with respect to d and b, or if you just change the differentiations, you can write like that, dq with respect to dt, because that is not a vector, and this is dl cross b, and rate of change of charge, that can be written as current. So we can write dl cross b, that is df. So since the conductor is made large number of element, so the total force, if we want to find the the total force that is experienced, the total force experienced by the conductor, total force experienced by the conductor, if we write is fm, it is nothing but integrate of this, and you can write I dl cross b, and you can put dl, integrations of dl can be written as l, so you can write like that, I l cross b. Or that the magnitude, if we consider the magnitude of this, that is nothing but bil, this is sine theta. So that is another thing, that means the same thing, that means we are getting the magnitude of the force, that is q v b sine theta, and similarly we can derive that magnetic force can be written in another format, that is nothing but bil sine theta. So here what we Yes. Now the thing is, there are three quantities. That means one extra quantity that comes, that is force. Because in the previous thing, when we are dealing with the corkscrew or right hand thumb rule, whatever be the thing,
স্যার
বলো।
স্যার বলছি এই ডেরিভেশনটা আরেকবার বলে দেবেন?
এই ডেরিভেশনটা বুঝতে পারোনি?
স্যার আরেকবার বলে দিন না।
Okay, the derivations is like that. আমরা in that particular case কি ধরেছি, আমরা একটা ম্যাগনেটিক ফোর্স বার করতে চাই, কখন? একটা কারেন্ট ক্যারিং কন্ডাক্টর, যেটাকে আমি ইউনিফর্ম ম্যাগনেটিক ফিল্ডে প্লেস করেছি। সো আমরা কি ধরেছি, যে এটা যদি ইউনিফর্ম ম্যাগনেটিক ফিল্ডে প্লেস করি, আমি ধরে নিচ্ছি স্মল এন হচ্ছে একটা নাম্বার অফ ফ্রি ইলেকট্রনস পার ইউনিট ভলিউম কন্ডাক্টরে আছে, এবং আমরা ধরে নিচ্ছি এ হচ্ছে একটা এরিয়া অফ ক্রস সেকশন অফ দ্য কন্ডাক্টর। আমরা তাহলে কি জানি, দেখে এসেছি যে একটা ইলেকট্রন যদি থাকে, তার উপর ম্যাগনেটিক ফোর্স হচ্ছে ই ভি ক্রস বি, অ্যান্ড দ্যাট ইজ এ নেগেটিভ সাইন বিকজ দ্য ইলেকট্রনিক চার্জ ইজ নেগেটিভ, অ্যান্ড ডিরেকশনস অফ দ্য ইলেকট্রিক, যেখানে ইলেকট্রনস গুলোর ডিরেকশনস ইজ অপোজিট টু দ্য ডিরেকশনস অফ কারেন্ট, যেটা আমরা জানি। সো এটা আমরা বার করলাম একটা ইলেকট্রনের জন্য। এখন আমাকে কি করতে হবে, এই টোটাল আমি কি করতে পারি, একটা স্মল এলিমেন্টাল এরিয়া কনসিডার করছি ডিএল, এবং ডিএল এ তাহলে টোটাল নাম্বার অফ ইলেকট্রনস এন যদি ধরে নিই পার ইউনিট ভলিউমে, তাহলে ভলিউমটা হচ্ছে ক্রস সেকশনাল এরিয়া এ ইন্টু ডিএল, and the thing is that cross sectional area A into dl, and this is the corresponding volume, and the thing is that that should be multiplied with n, that will give you the number of electrons in the small elemental area. So যদি আমি টোটাল ফোর্স বার করি এইটুকু এলিমেন্টাল এরিয়া ডিএল এর মধ্যে, সেটা হচ্ছে পার ভলিউম নাম্বার অফ ইলেকট্রনস, এটা হচ্ছে টোটাল ভলিউম, আর প্রত্যেকটা ইলেকট্রনের জন্য ফোর্স হচ্ছে এফএম, এবং এফএম এর ভ্যালু হচ্ছে ই ইন্টু, এবার আমরা জানি কি ইলেকট্রনিক চার্জ যদি এটার সাথে মাল্টিপ্লাইড করি, এন হচ্ছে নাম্বার অফ ইলেকট্রন, ই হচ্ছে ইলেকট্রনিক চার্জ, আর এডিএল হচ্ছে পার ইউনিট ভলিউম, তাহলে মাল্টিপ্লাইড করলে পার ইউনিট, দ্যাট ইজ নাথিং বাট দ্য টোটাল চার্জ দ্যাট উই উইল গেট। দ্য টোটাল চার্জ ইজ নাথিং বাট ডিকিউ, that is the dq, and the drift velocity is nothing but dl with respect to dt, that is nothing but dl with respect to dt, and that is a negative sign because dl is in the opposite directions of the velocity. So আমি এখানে velocity জায়গায় just dl with respect to dt যদি প্রডিউস করি, নেগেটিভ নেগেটিভ should be cancel out, এবং na dl e that should be equivalently written as a dq. So the thing is that df can be written as dq, and আমি v এর জায়গায় dl with respect to dt বসিয়েছি, এবং this is b। এবার আমি dt টাকে যদি বাইরে আনি, it should be dq with respect to dt, and that is dl cross b, and dq with respect to dt is nothing but current, so we can write like that, current I multiplied by dl cross b, that is the thing. Or you can say, if we integrate it, the integration is upon dl, and that can makes you l cross b. So this is nothing but, that the total force that is experienced by the conductor. That means we can write the force as qvb sin theta, as well as we can write it by bil sin theta. So now my question is, since there is a force, there is magnetic field, and there is current, so how can we find the directions of this? And that can be found by using, that means Fleming's left hand rule. That is one of the important rule by which we can find the directions of force depending on the magnetic field and current transmission. That is the left hand rule, and the left hand rule is like that, stretch the left arm, stretch the left hand such that, if this is the left hand, and say this is the finger like that, and the rest of the two are like that, whatever be the thing. The main thing is that we have to stretch the left hand such that the forefinger, the central finger, and the thumb, that are mutually perpendicular to each other, that three are mutually perpendicular to each other. One is the forefinger, one is the central finger, and one is the thumb. And when the forefinger points in the directions of magnetic field, that means forefinger will point in the direction of magnetic field, and the central finger that will point in the directions of current, that means it will give you the directions of current. Then what you will find, the thumb that will give the direction of force, that will give the direction of force. That is the the Fleming's left hand rule that we already know that. So the thing is that there is another some derivations, then we will solve some problem. The thing is that there is one of the important derivations that may come in your, that when the charge particle that is moving in electric and magnetic field, that means the thing is that when the charge particle, when the charge particle that is moving in electric and magnetic fields, that is the thing, that means charge particle that is moving in electric and in magnetic field. So what we think, that means first we consider that when the charge particle is moving in uniform electric field, that means the first case we are considering when the charge particle, when the charge particle that is moving in uniform electric field. That means the questions will come maybe that you have to find that descriptions of the charge particle, or they will ask you what should be the locus of the charge particle when the charge particle is moving in a uniform electric field. That is the questions. The charge particle when it is moving in a uniform electric field. So we are considering an uniform electric field E that is set up between two oppositely charged parallel plate. That means if we consider, say this is the parallel plate, say this is the the parallel plate, and the electric field will be uniform electric field will be set up like that. This is the uniform electric field will be set up like that. And of course that is we can take, if we take a middle point O, and that is the x axis, and that is the say y axis. Now what will happen, say in that particular case a positively charged particle having charge plus q, that means a positively charged particle. So let what I am saying, that a, that is also another derivation, that means a positive positively charged particle, a positively charged particle, say having charge plus q and mass m, that enters at O, that say entered at O with say velocity, v along x directions, with velocity v along x directions, say in the region of electric field E, in the region of electric field E. So now you know that what should be the then force that is acting on the charge q, that means when it is entering in that particular field, say with the velocity v, then this is the charge plate, of course this is the charge plate. So what we can say, that a force will be acting, that means a force that acting on charge q, that is due to E, the force is nothing but F is equals to QE. Then what will happen? And of course the directions of the force is along the directions of electric field. So the charge particle will be deflected accordingly. So what should be the acceleration? If there is a force, then we know the acceleration is force per mass, that should be QE by m. So the acceleration, that means the charge particle will accelerate in the directions of electric field. Electric field is So it will be accelerated in the direction of the electric field, like that. It will be accelerated to the direction of the electric field, and as soon as the particle leaves the region of the electric field, it travels in a straight line due to the inertia of the motion, and say it can hit, if we place a screen there, say we are place a screen there, then what will happen? They will move like that, acceleration with acceleration in, and after just cross it, it will go to the straight line and it will hit the screen at that particular point. So what I am saying, that is the force, that means within the electric field, that will move with an acceleration, but when, as soon as, that means as soon as the particle, as soon as the particle leaves the region, as soon as the particle that will leaves the region of electric field, you know it travels in a straight line, it travels in a straight line due to inertia of the motion, due to inertia of the motion, due to inertia of the motion, and এটা কি করবে, হিট করবে, and it hits, কি করবে, হিট করবে কোথায়, স্ক্রিন কে, কোন পয়েন্টে, at p, and let I have to find the locus. It may be possible that they have to ask you to find the locus of the particle. That means the thing is that, then what we can say, let t be the time, let t be the time that is taken by the charged particle, taken by the that charged particle to traverse the region of electric field of length x. Let t be the time that is taken by the charged particle to traverse the region of the electric field of length x, and let y be the distance that is traveled by the particle, traveled by the particle along y directions, along y directions. That means what I am saying, that means in that particular t be the time that is taken by the charged particle to traverse the region of electric field of length x. That means we are saying this is the length x, and that is nothing but the length y, that is nothing but the length y, because we have to find the locus depending on x and y. So if you use the formula, that means what we know, that s is equals to ut plus half of at square, and we can, there is a horizontal motions and there is as well as a vertical motions. So if we consider the horizontal motion, that means for, if we consider horizontal motions, so in case of when we are considering the horizontal motions, the distance that is travel is x, velocity we are taking as v, and acceleration is 0, because that no force acts on the particle along x directions, that will be act on the y directions. So from that figure what we will get, if we put this, that means x is equals to v into t, that is the first equation, or you can say t can be written as x by v, that we will get. And if we consider for vertical motion, for vertical motion, that means when the particle is moving along y directions, initially the particle was moving along x directions, but in that particular case they will move in the y direction, so the velocity is equals to 0. Then you can say y can be, initially is 0 because initially the particle is moving along x directions and there is no velocity along y directions, so initially y is 0, and if we put in this particular formula we will get half of at square. And what is a, we know what the value of a, we already found it, a is nothing but qe by m, that is nothing but force by qe by m, what we get about the accelerations. So this is qe by m, that is the corresponding acceleration, and t we will find from this particular equation x by v. So x by v whole square. So what we know that, or you can say that y is nothing but qe x square by 2m v square, or you can write it, say, that can be w x square, where w is a constant and that is qe by 2m v square, that is you can take as a constant. So you will get the equation y equals to some constant into x square. So what is the equation? That is the equation of the parabola. That means that is nothing but the equation of parabola. That is, that equation of, parabola. That means what directions we will get? That means a charged particle, if it moves in uniform electric field, that will follows a parabolic path. So that means a charged particle, particle that moving, in a uniform, electric field, that follows a parabolic, parabolic path, path, that you should know. So it may be, the questions may become that the energy that you will gain by the charge while passing through the potential difference, that can also be found if we equate the kinetic energy with q and v. That would be the another case. But the thing is that you should remember, that means a charged particle, that is moving in a uniform electric field, that follows a parabolic path. That is the main thing that we deduce from there, and we've deduced the derivations. There is also another important thing, that is what should be the path when the charged particle, that is moving, in a uniform magnetic field, uniform magnetic field magnetic field. So what should be the locus? What do you know about that? That means when the charged particle moving in a uniform magnetic field, কি হয় বলো দেখি, জানো?
স্যার যদি হচ্ছে ডিপেন্ড করে যে কোন ডাইরেকশনে যাচ্ছে।
আচ্ছা, ডিপেন্ড করে কোন ডাইরেকশনে যাচ্ছে। কোন ডাইরেকশনে গেলে কি রকম হয়?
ইয়েস স্যার। স্যার যদি সোজা যায় তাহলে আনচেঞ্জ থাকবে স্পিড, যদি পারপেন্ডিকুলার যায় তাহলে সার্কুলার পাথ।
Okay, very good. So the thing is that the case one, what is thing? That means when the moving, the charged particle, does not experience any force, or if its motion is parallel or anti-parallel. That means a moving charged particle that does not experience any force if its motion is either parallel or anti-parallel to the magnetic field, because magnetic force q v cross b, that means dv sin theta. If this is theta is 0 or 180 degree, then the value is 0, so we will get not any force. But the case 2, that is important, that means when that charge particle, moves at right angle, to the magnetic field, that you have to find. So in that particular case, what I am talking, that means the magnetic fields that is perpendicular, we already give the significance of the notation, that this particular notation, when we are giving cross, that means the magnetic field is acting to the plane in the downward directions, that can be denoted by that. And say when a uniform magnetic field that is acting perpendicular to the plane of the paper and directed into the paper or downward, whatever, that can be directed by these cross signs, and let a charged particle having charge plus q, let we can say a charged particle, a that charged particle having having charge that is plus q, that enters the region of the magnetic field with that the velocity that is v, and that is perpendicular to magnetic field. Then what we will find that, what we know, that force is nothing but v cross b. So, if we consider the magnitude of this force, that is q v b sine this is 90 degree. So, this is q v b that we will get, and this force is always perpendicular to the direction motion of the particle and as well as the magnetic field. That means, if you say, if the m be the mass of the charged particle and r be the radius of the circular path, then the necessary centripetal force that required by the particle to move in a circular path is mv square by r. Because what will happen here, say there is a charge and we know that that is a charge, that the positive force will be acting there and velocity will be acting like that, and when it moves to this, say at that particular part, here also the velocity will be directed like that and the force will be directed like that. That means actually it produce a circular path. It produce a circular path, because in case of circular path, if we consider any point, if we say the charge will be there, then we know that force will be acting and the v will be perpendicular, and they both are perpendicular at each and every time. So, that makes a circular orbit. And we know that if m be the, they will ask you the questions that what should be the radius of the circular path. It may be the question comes like that, when a charged particle is moving in a uniform magnetic field, then we know that that produces a circular path. Now they ask the questions like that, what should be the radius of the path, what should be the time period that will take, that type of questions may come. So, the thing is that if m be the the mass of the charged particle, if m be the mass of the charged particle and say r be the radius of the circular path, then what do you know, that the necessary centripetal force that is acquired by the particle, the that necessary centripetal force that is required by the particle, that is required by the particle to move in circular path, that is mv square by r, and that should be balanced with this magnetic force. That means mv square by r, that can be written as qvb, and the r is nothing but mv square by qbb. You can write like that. So, this is this is known as the radius of circular path, or you can write in a different format. That means, if we find the radius of circular path, you can write like that, r is equals to mb, that means this v square and v will be cancelled out, mb by qb, or you can write like that, q by mb. This is the radius of the circular path that is directly proportional to the speed of the particle and the mass of the particle. So, what we will find, that the radius of the circular path that is directly proportional to the speed of the particle and as well as the mass of the particle. So, it is clear that the slow moving charged particle that move in small circles and the fast moving charged particle that will move in large circle. So from that we will get the the time period of the charged particle, and the time period is nothing but distance by speed, you can like that, and distance is nothing but circumference of the circle by speed. So this is 2 pi by v, and the value of r we can put there mb by qb, and that is 2 pi m by qb. So also it is clear that the period, that means the time period or frequency, whatever be the thing, that is independent of the speed of the particle and radius of the circular path, because you just see that this time period or frequency, because frequency can be represented with respect to time period, that is that independent of the speed of the particle and radius of the circular path, and it depends only on the magnetic field and the nature of the particle, and that fact is used to accelerate the charged particle in cyclotron or any particle accelerator, especially in cyclotron. We are using this particular principle in the cyclotron. And of course, if you want to find the frequency, that is 1 by time period. So this is qb by 2 pi m. And of course, angular frequency is equals to 2 pi into linear frequency. So it is nothing but qb by m. So that is the corresponding formulas that we ask. And this is the second case. This is the second case. That means when the charged particle is moving in a uniform magnetic field. The first case is when it is moving, particle does not experience any force when its motion is parallel or anti-parallel, and when it is a perpendicular, that means right angle to the magnetic field, then its motion is circular. Now the third case that we can say, that is nothing but when the charged particle moves at an angle to the magnetic field other than 0 degree, 90 degree and 180 degree. That is the case 3. That means when the that charged particle, when the charged particle moves an angle to the magnetic field, at an angle to the magnetic field, that is other than 0 degree, 90 degree and 180 degree, other than that, then what will happen in that particular case? That is one of the interesting phenomenon that we observe, that say if we consider a charged particle, that means say if we consider this is x axis, this is a y axis and this is a z axis, and say a charged particle that is moving with the velocity v with an angle theta. That means what I am taking, that we are taking that consider a charged particle, of say mass m, that moving with velocity v at an angle theta with the direction of magnetic, with the directions of magnetic field, that is b. And of course, when the v will be moving with some angle, that means it has two components. One is along x axis, you can say v cos theta, and along y axis, this is v sin theta, that is vy. And what we find, that v sin theta component is perpendicular to the directions of motion. That means that will produce a circular motion, and v cos theta component, that will move the particle in the forward directions. So that means what we can say, that will produce a helical structure. So what I am saying, that now this Vx is equals to V cos theta is the component, is nothing but the component of the velocity v along the directions of b, along the direction of B, and Vy is equals to, that is V sin theta, that is the component, is the component that is perpendicular to the magnetic field. So, what will happen? The charged particle that will moves with constant velocity v cos theta along the magnetic field, and as no force acts on the particle, so it moves parallel to the magnetic field, and there is a component which is v sin theta, that is perpendicular to the directions of B. So, the particle that will experience a force, and under this force the charged particle that will tend to move in a circular path, in a perpendicular, because that is the v sin theta which is perpendicular, that means that will produce a circular path, and the thing is v cos theta, that means it will moves the particle in the forward direction. So, it will be moves like that, it will be moves like that. The thing is that, of course, I think that should be understandable, that means the charged particle that will moves with constant velocity v cos theta, because along v cos theta that is a parallel to the magnetic field, that means there should be no force, but it will moves the particle forwardly, there is no force that is acting, but v sin theta that is perpendicular to the magnetic field. So, the particle will experience a force, and of course, under this force the charged particle tends to move in a circular path in a plane that is perpendicular to the magnetic field. So, of course, you know that the centripetal force that is required to move the particle in a circle, that will be provided by the magnetic Lorentz force, and we know that mv square by r, but here the v is nothing but v sin theta whole square by r is equals to q, this is v is equals to v sin theta q v b, and sin 90, because here the v is the v sin theta, so that is q v b sin theta, or from that what we will find, the value of r is equals to mv sin theta by qb, that is nothing but the radius. That means in the previous case what we will find, that is qb by qb, mv by qb, but in that case a sin theta component will come out, and the time period is nothing but same thing is q 2 pi r by here the v sin theta. So, this is 2 pi by v sin theta, and the value of r is mv sin theta by qb, and this is nothing but 2 pi m by qb, and of course, the same thing, that means time period or frequency that is independent of the velocity of the charged particle. And there is a concept which is called pitch. This is a concept, that means this is the helix structure, that is the helix structure, and you should find the pitch, that means the questions may come, you have to find the pitch. And what is pitch? It is nothing but that the linear distance, it is nothing but the linear distance that is traveled by the linear distance that is traveled by the charged particle in one rotation. Linear distance that is traveled by the charged particle in one rotation, that is called pitch of the helix, that is called pitch of the helix. And it is nothing but if we want to find the pitch of the helix, then what is this? If it is denoted by p, the distance, the velocity along x-axis is v cos theta, and the time period is t, that we will find. So, it is nothing but v cos theta, and the time period is 2 pi m by qb. So, this is nothing but the pitch of the helix. So, that may be the questions, that what should be the pitch of the helix structure. So, now the thing is that when the charged particle that is moving in combined electric and magnetic field, because in the previous cases we are considering different facts where we will see that either the charged particle is moving in electric field, or either the charged particle will be moving in a magnetic field. But if the thing is that if the charged particle, if that the charge particles, the charge particles, moving in combined electric and magnetic field. That means charged particles that is moving in combined electric and magnetic field. The first thing that you should know, that is velocity selector, that is velocity selector, that is also one of the important, or in somewhere that is known as velocity filter, that is velocity filter. That is also when the charged particle that is moving in combined electric and magnetic field. That means this particular velocity selector is set up to select charged particle of a particular velocity from a beam that is passed through a space having crossed electric and magnetic field. That means there are mutually perpendicular electric and magnetic field, and we are two equally opposite charge. That means say this is the two equally and oppositely charged plate. This is the two plate, say two equally and oppositely charged plate. That means if we take this is a positive and that is a negative, that means that such that the electric field is set up from positive to negative plate. Electric field is set up between positive to negative plate, and a magnetic field B, say that is given a magnetic field that is perpendicular to the electric field and that is directed into the page. That means here is also magnetic field is also acting and in that particular direction. That means electric and magnetic field both are acting on that, and there is a charged particle that will be moving through that with some velocity. This is v, this is a charge. So what we know, that let a charged particle, say charge is q, that is enter in a region with the velocity v where the mutually perpendicular electric and magnetic field are exist. So what we know, that electric field if exists and there should be force, and which is QE, and the force acting on the particle that is acting downwards, and the thing is that there is also the force due to the magnetic field, because both are present, and this is nothing but q v cross b, and of course v and b are perpendicular to each other. So if we consider the magnitude of the force, that means if we consider the magnitude of the force, that is q v b, because v and b are perpendicular, and this force deflects the particle in the upward direction because magnetic field will be directed like that. So the thing is that the value of E and B, this value of electric field and the magnetic field are so selected that electric force and magnetic force become equal and opposite. That means it should be such that the magnitude of the electric force should be equals to magnetic force due to the magnetic force, and that is nothing but the velocity selected. That means we can say this is QE, that can be written as QVB, or V is nothing but E by B. V is nothing but E by B. So only those particle of the beam which moves with a velocity given by this equation, that will pass through the slit. That means when if the velocity of the particle should be like that E by B, then only that particle will be passed through the slit. The particle that is moving with velocity greater than or lesser than the velocity given by the equation will not pass through the slit. That is the main thing that you should understand. That is why that is called velocity selector. That means it will pass the particle whose velocity is equals to the magnitude of E by B. That is the thing. That means the main observations, that means only those particles of the beam which move with with a velocity that is V is equals to E by B will pass through slit. The particles that the particles moving with velocity you know velocity greater than or less than the velocity E by B will that the particle that is moving with the velocity greater than or less than the velocity given by the that will not pass through the slit. That is the main observations, and that's why that is known as velocity selector. There is an instrument which is mass spectroscope that actually works on the principle of velocity selector. That means this mass spectroscope is nothing but a device which actually used to separate according to their specific charges, whatever be the thing. The next thing that we know, that is the first part. That means when the charged particle is moving with combined with electric and magnetic field, that one of the example is velocity selection, and the another example that is known as cyclotron. And of course that is a one type of particle accelerator. That means that when you are doing nuclear experiments, that a high speed neutrons or something will be that will come with some velocity and it will hit the radioactive element, then the process will start. So how can we produce this high velocity neutron? That would not be produced by cyclotron, but that would be produced by some particle accelerator. And cyclotron is one type of particle accelerator where the particles, like that in that particular case the electrons, the electron will gain some energy and some velocity such that it can be used for some experimental purposes. That means we can say that can be used to produce radioactive material for medical purposes. That means for the purpose of diagnosis and treatment of chronic disease, we are passing some electrons, like that when we are doing some MRI scan or something else. And that type of principles, that is a we use the cyclotron principle somewhere there. Or you can say that will be used to synthesize the fresh substances, that can be improve the quality of solids by adding ions, and of course that should be used in several purposes. But that is the principle, that is one of the particle accelerator. There are lots of particle accelerator, but in your syllabus that is only one that you have to know. There are betatron, there is all other particle accelerator where the neutron or other positively charged particle can be used. So the what is a cyclotron? It is that is nothing but a device, that is a device used to accelerate positively charged particle. That is used for only positively charged particle. That is not for electron, because electron will not work in cyclotron because it has a less mass. So before gaining the energy, it will out of the cyclotron. There is a reason behind that. So the cyclotron, that is a device that is used only to accelerate the positively charged particle. That is positively charged particles, like that you can say protons or alpha particles. That is protons or alpha particles. That means proton অথবা alpha particle positively charged পার্টিকেলের জন্য এই সাইক্লোট্রনটা ইউজ হয়। আদারওয়াইজ দেয়ার ইজ ডিউট্রন, আয়নস এইসবের জন্য। বাট পার্টিকেল অ্যাক্সেলারেটর কিন্তু অনেক রকম হয়, তার মধ্যে সাইক্লোট্রন হচ্ছে একটা এক্সাম্পল। বিকজ ইলেকট্রনকে কিন্তু আমরা সাইক্লোট্রনের রেসপেক্টে করতে পারছি না, কারণ তার মাসটাও খুব কম এবং নেগেটিভলি চার্জ পার্টিকেল। দেয়ার আর সাম রিজন যেটা সাইক্লোট্রনে ইলেকট্রনকে আমি পার্টিকেল অ্যাক্সেলারেট করতে পারছি না। এবং পার্টিকেল অ্যাক্সেলারেটর মানে কি, মানে এর ভেতরে পার্টিকেলটা ঘোরার সময় একটা এনার্জি গেইন করছে এবং তার জন্য ওর একটা ভেলোসিটি বাড়ছে এবং সেটা বাড়িয়ে কি হচ্ছে অন্য কোনো এক্সপেরিমেন্টে আমি সেটাকে কাজে লাগাচ্ছি। যেমন ওই যে তোমায় বললাম যে নিউট্রন, হাই স্পিড নিউট্রন আমাদের দরকার কিসের জন্য দরকার, যখন আমরা একটা রেডিও অ্যাক্টিভ এলিমেন্টকে গিয়ে হিট করছি। তার মানে আমাকে তো একটা পার্টিকেল অ্যাক্সিলারেটরে নিউট্রনকে প্রথমে এনার্জি দিয়ে ওই পরিমাণ ভেলোসিটি গেইন করাতে হবে। ওই পরিমাণ ভেলোসিটি যদি নিউট্রনটা গেইন করে তবেই তাকে আমি একটা পার্টিকুলার এক্সপেরিমেন্টে কাজে লাগাতে পারবো, এবং that's why particle accelerator is important. But this cyclotron particle accelerator that is used to accelerate only the positively charged particle. That means either proton or alpha particles or neutrons or ions. That is the thing. And the thing is that what should be the principles? That means if we, in what principles actually the cyclotron will be acting, because in your examinations, board examinations, you have to explain that. That means it works on the principle, that means when you know a positively charged particle, when a positively charged particle, when a positively charged particle is made to move time, and again in a high frequency, again in a high frequency electric field and using strong magnetic field, and using strong magnetic field, it gets accelerated, and acquires sufficiently large amount of energy. That is the corresponding principle. And if they ask about the constructions, that means if you just know the thing, then you will explain it. That means, say this is the magnetic field, this is the south, and say that is the north part of the high velocity magnet, and we are producing here two D's, that is called it is looks like a D, so that's why it called D's. I am explaining that, and there is a high frequency oscillator is connected there. This is high frequency oscillator means it will change the polarity. It consists of two hollow D-shaped metallic chamber. That means this is hollow D-shaped metallic chamber, and এই চেম্বারটা কি হচ্ছে, এই চেম্বারটা এই হাই ফ্রিকোয়েন্সির সাথে অ্যাট্রাক্টেড। এখন কি হচ্ছে, আমরা তো জানি এখানে হচ্ছে যেহেতু আমি ম্যাগনেটিক ফিল্ড দেওয়া আছে, এর ভেতরে একটা দ্য ম্যাগনেটিক ফিল্ড বি কাজ করছে, বিকজ দিস ইজ এ হাই ম্যাগনেটিক ফিল্ড দ্যাট ইজ গিভেন। এখন কি হচ্ছে, আমি কি করছি, ধরো একটা পার্টিকলস ইনসাইড দ্য ডি that are shielded from the electric field, but magnetic field is acting, মানে within this D ম্যাগনেটিক ফিল্ডটা অ্যাক্টিং করতে পারছে, বাট ইলেকট্রিক ফিল্ডটা অ্যাক্টিং করতে পারছে না, সেইভাবে আমরা করে নিয়েছি। এবারে কি হচ্ছে, ধরো একটা পজিটিভলি চার্জ পার্টিকেল ইট এমিটেড ফ্রম দ্য সোর্স, ধরে নিচ্ছি আমি একটা পজিটিভলি চার্জ পার্টিকেল দ্যাট উইল বি এমিটেড ফ্রম দ্য সোর্স, ধরো সোর্সটা হচ্ছে এই মিডিল, দ্যাট ইজ দ্য সোর্স। একটা পজিটিভলি চার্জ পার্টিকেল আছে দ্যাট ইজ এমিটেড ফ্রম দ্য source, then what will happen, ধরো D2 টাকে is negatively charged and D1 কে positively charged, ধরো এটা হচ্ছে D1, এটা হচ্ছে D2, আমি প্রথমে ইনিশিয়ালি ধরে নিচ্ছি that D2 টা is negatively charged, D1 টা পজিটিভলি চার্জ আছে and এটা নেগেটিভলি চার্জ, এবং এখানে আমি একটা পজিটিভলি চার্জ পার্টিকেলকে দিয়েছি, তাহলে কি হবে, চার্জটা প্রথমে এই D1 এ নেগেটিভ দিকে অ্যাট্রাক্টেড হবে, কারণ পজিটিভ চার্জ নেগেটিভলি অ্যাট্রাক্টেড হবে। এবারে যেই এইখানে আসবে, আমি তখন এই যে হাই ফ্রিকোয়েন্সি অসিলেটর আছে এটা দিয়ে কি করব, এর পোলারিটিটাকে চেঞ্জ করে দিয়ে এটাকে নেগেটিভ করে দেবো, এটাকে পজিটিভ করে দেবো, তাহলে কি হবে, ও আবার এটার দিকে অ্যাট্রাক্টেড হবে। আবার কি করব, আবার চেঞ্জ করে যখন এখানে আসবে এটাকে পজিটিভ করে দেবো, এটাকে নেগেটিভ করে দেবো, তার মানে ওটা আবার এটার দিকে অ্যাট্রাক্ট, তার মানে কি হবে, ও এখানে এরকম সার্কুলার অরবিটে ঘুরতেই থাকবে, এরকম সার্কুলার অরবিটে ডি এর মধ্যে ঘুরতেই থাকবে, এবং যত ঘুরবে তত কি হবে, ওর এনার্জিটা এনার্জিটা অ্যাকোয়ার করবে, এবং এই প্রসেসটা কন্টিনিউ করবে যখন ধরো প্রোটনটা রিচেস করবে পেরিফেরি, মানে পেরিফেরিতে আইদার রিচ করে যাবে, তখন আমি কি করব, প্রোটনটাকে ডিফ্লেক্ট করব ডিফ্লেক্টিং পেড দিয়ে, মানে ধরো এখানে যখন পৌঁছে যাবে, তারপর আমি কি করব, একটা ডিফ্লেক্ট করার পর আমি কি করব, এটাকে বের করে নেবো, একটা পার্টিকুলার পারপাসে ইউজ করে দেবো, ধর এটা হচ্ছে টার্গেট, টার্গেটে আমি হিট করাবো উইথ সাম থিং। এটাই হচ্ছে বেসিক থিওরি, আর কিছুই না। তোমাকে যদি থিওরিটা এক্সপ্লেন করতে যাই তাহলে এইভাবে বলে দিলেই হবে যে আমি দুটো ডি নিয়েছি, ডিটাকে একবার পজিটিভ একবার নেগেটিভ নিয়েছি বাই ইউজিং দ্য ফ্রিকোয়েন্সি হাই ফ্রিকোয়েন্সি অসিলারেটর, এবং এই পজিটিভ নেগেটিভের চেঞ্জেসের জন্য কি হচ্ছে, এই সার্কুলার অরবিটটা জেনারেট করছে, বিকজ এখানে আমি এইভাবেই রেখেছি যে ম্যাগনেটিক ফিল্ডটা পারপেন্ডিকুলার টু দ্য ইলেকট্রিক ফিল্ড, এইভাবেই আমরা এই জিনিসটাকে রেখেছি, এবং সেখান দিয়ে তোমাদের আগের মতো প্রিন্সিপাল, দ্যাট মিনস হেয়ার দ্য circular orbit means this is mv square by r, that would be balanced with the q and v and b, and from that we will get the radius of the circular orbit, this is mv by qb, and we will get the time period, that is distance, because that is a semicircle, that means if we take about the total time period, that is same as that 2 pi m by qb, that is similar way. If we find the cyclotron frequency, cyclotron frequency is 1 by t, that is nothing but qb by 2 pi m, and if we find the energy gain, that means that is nothing but half of mv square, and from that we will get the value of v, and v is nothing but qbr by m, so half of m, that is qbr by m, that is whole square, and that will come out u square b square r square by 2m. You have to remember it for if you want to do the problems. And of course, what are the corresponding limitations of the cyclotron? There are no limitations, that the cyclotron cannot accelerate the the uncharged particle like neutrons. Cyclotron cannot accelerate because they have a small mass, and that type of things, because and that cyclotron cannot accelerate electrons, what I am saying, because they have a small mass, and because electrons start at a very high speed when they gain small energy in the cyclotron, and oscillating electric field makes them to directly quickly got out from the phase with the high velocity, because or যেহেতু that ভেরি স্মল মাস, ও বেশিক্ষণ সাইক্লোট্রনে থাকতে পারে না, এবং তার জন্য বেশি এনার্জি গেইন করতে পারে না, তার আগেই ও বেরিয়ে যায়, এবং positively charged particle having large mass that also cannot move at limitless speed in the cyclotron, অতটা আমাদের সাইক্লোট্রনে হয় না। এবং সাইক্লোট্রনের তো আমি তোমায় বললামই যে কোথায় কোথায় সাইক্লোট্রনটা আমাদের কাজে লাগে, that is the one of the important thing যেটা আমাদের বিভিন্ন জায়গায় কাজে লাগে। So আমরা let's see what are the different problems that may come from this particular chapter, that is that moving charge and magnetism. So তোমাদের নিটে 2019 একটা কোশ্চেন এসেছিল, and I think you can solve it, that means that is the question is they will like that ionized hydrogen atoms and alpha particles, ionized atom and alpha particles with same momentum enters perpendicular to a constant magnetic field, that is B. The ratio of their paths ratio of their path will be what would be the, and I think you can give me the answer, that ionized hydrogen atom and alpha particle with same momenta that will enter perpendicular to a constant magnetic field B, and you have to find the the ratio of their paths that will be. So এটার অ্যান্সার কত হবে? বলো ঝটপট। কত হবে বলো?
স্যার অপশন বি।
That should be option B. Okay, very good. That should be option B, because R equals to, that is mv by qb, and that is nothing but momentum by qb, and since P and B, for a given P, R is varies to 1 by Q, so what we will get, RH by R alpha, that is Q alpha by QH, that is nothing but 2 by 1. So we can say that that is the corresponding thing. So তাহলে দেবাদিত্য এই প্রবলেমস গুলো নাই আমরা করব, কিন্তু থিওরি গুলো কি বোঝা গেল?